Numbers have a strange fascination of their own, quite apart from their day-to-day use. Now here's a strange prediction with a three-figure number. Any 3 digits will do, but to show there's no cheating, I'll roll 3 dice. And I have the number 642. Now I'll put that into my calculator, 642, and then once again to give me a 6-figure number. Now there's no way I could possibly know in advance what this number would be, but luckily I do know it will divide exactly by 7. So divide it by 7 to give 91806. My luck is in. I predict that new number will divide exactly by 11. It does, 8,346. Wait for it. This new number I predict will divide exactly by 13. Divide that by 13 to give 642. The number I first started with. There on the 3 dice. Amazing! And I'll leave you to puzzle out why. But before you beat your head on the carpet, it's something to do with 1001. This programme is all about the power of numbers to affect our lives and direct our thoughts. Everything from planning your own home to puzzling out one of the world's oldest paradoxes. This paradox was thought of by an ancient Greek called Zeno. Zeno had an idea for a race between Achilles, a down-at-heel athlete, and a tortoise. It's a bit of a mismatch because Achilles can run 10 times faster than the tortoise. So the tortoise is given 100 paces start. Achilles runs the 100 paces and soon gets to the place from where the tortoise started. Meanwhile, the tortoise has gone a tenth as far as Achilles and is 10 paces ahead. By the time Achilles has run that 10 paces, the tortoise has gone 1/10 of that, 1 pace. Achilles runs this pace, but the tortoise has moved 1/10 of the pace and is still in front. Achilles swiftly runs this 1/10 pace, but the tortoise has moved 1/10 of a tenth, so it's still 100th of a pace in front. When Achilles has run this 100th of a pace, the tortoise is 1,000th of a pace in front, and so this comedy continues. Now the ancient Greeks knew by common sense that Achilles must pass the tortoise, but their best brains couldn't figure out how far the tortoise moved before Achilles reaches him. The tortoise always seems a fraction ahead, and the Greeks weren't very good at fractions. Nowadays we can sort this problem out with the power of numbers, but the Greeks had the wrong kind of numbers. They used the letters of their alphabet a bit like this. A to I represents our numbers 1 to 9. J to R is 10 to 90, and so on. As a result, they couldn't do sums on paper and found division especially difficult. Fractions like 1/10, 1 over 10, looked a bit like A over J. 100, 1 over 100, A over S. And it's not easy to see whether A over S is bigger or smaller than A over J. It's all very confusing and difficult to think about. In Europe, it took at least 2,000 years for the power of numbers to develop to the point where all of us can now help Achilles take on the tortoise. And I'll come back to this later. By the end of this programme, I should be able to work out exactly where the runner overtakes the reptile. For the ancient Greeks, it was the thought that counted, but nowadays we have all sorts of gadgets to help us with our digits.
Everyone there, sir, is £10. £10. Yes, then there's extra for the charger. I see. And then there's the VAT. Yes, of course. Well, how much is that in round figures? In round figures? Well, why don't you add it up on your machine? That's a good idea. £10. That's a good idea. Come in. Yes. £10? £10. Yes. Now, the charger. £2.75. £2.75. Yes. Don't forget the VAT. VAT. Oh, that's fantastic. I'll take that. How much is that altogether? £332. Oh, thank you very much. I'll save a fortune with that. Oh, of course you will.
Who knows when people started to count and calculate? 30,000, maybe 50,000 years ago. Long before there were proper symbols for numbers, there were plenty of reasons to count. How many hunting trips have you been on? How many enemies have you laid low? Each one recorded as a mark on a piece of wood or bone. The move from counting to adding was straightforward. To add, I just add a few more marks. Now, adding is the basis of all arithmetic. If I have 5 and I want to subtract 3, I could say, what must I add to 3 to get 5? And if I want to multiply 5 by 3, I could say instead, what will I get if I add 5 and 5 and 5? As for dividing, what is 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, divided by 3? Well, I could turn this round and say, how many 3's must I add together to get 9? With any calculation, ancient or modern, try to look for other ways to get to the answer. With numbers, there's always more than one way to make a match.
Johann Kepler, a German astronomer best known for his laws of planetary motion, was so in love with the power of number that he also made use of it in his private life. The story goes that as a middle-aged widower, Kepler decided to apply his knowledge of number to matrimony. So he listed the 11 young ladies eligible for the vacancy and then the various qualities he desired. He proceeded to calculate his perfect match by giving each candidate marks for each quality on a scale of 1 to 10. To determine which woman had the right proportions, he added up the scores. With his mathematical proof in hand, Kepler planned to convince his lucky lady of their compatibility. Some chance. Women, being notoriously less rational than numbers and infinitely more sensible than astronomers, the highest-ranking prospects refused to obey the dictates of mathematics and declined the honor of becoming Mrs. Kepler. Only by settling for a smaller numerical value was Kepler able to complete the equation of matrimony, or, as he put it, God led him back to number 5. On the 30th of October, 1613, Kepler married the 24-year-old Susanna Reutinger. Thus, number 5 was subtracted from the list of eligible ladies, added to the Kepler family, and in a position to go forth and multiply.
What did the Romans ever do for maths? Roman numerals, that's what. 1, 5, 10, 50, 100, 500, and 1,000. This form of writing numbers proves to be so popular that there are still lots of them around today, on clocks and watches. Even a number at the end of this programme. Anyway, doing sums using Roman numbers isn't much easier than using Greek ones. For anything that couldn't be done in the head or on the fingers, the Romans, like many others, used either an abacus or a counting board, something like this. There's a set of columns representing the units, tens, hundreds, and thousands, so it's a decimal system. The numbers are shown by little pebbles, so this gadget is a calculator, but it isn't electronic. Now here is a number, 268. If I want to add 123, I just put in more pebbles. 3 in the units column will give me 11 altogether. So, quite literally, I carry 10 over into the tens column. But because in this column each pebble is worth 10 units, I just put 1 down. Now I'll add the 20, which is 2 tens, 10, 20, and the 100, and count up the pebbles in each column to give the answer 391. Now, counting boards and frames fix the idea of calculating in columns just as we do today. Although Roman numerals caught on in a big way, they are clumsy, and they held back the development of arithmetic and the power of numbers in Europe for more than 1,000 years. Because calculations were so difficult, they tended to be the job of professional mathematicians. Nowadays, any one of us can make a living just by being nifty with our digits. Invent a new board game, and you could be on your way to fame and fortune.